Welcome to the next section, Introduction to Docker. This section explains the idea of containerization and the fundamentals of the Docker tool. This chapter also shows how to use Docker commands, package an application as a Docker image, publish Docker container ports, and use Docker volumes. Now we move on with the first video of this section. What is Docker? In this video, we are first going to learn the differences between containerization and virtualization. Then we will look at the need for a Docker. Docker is an open source project designed to help with application deployment using software containers. Docker, therefore, in a similar way as virtualization, allows packaging an application into an image that can be run anywhere. Containerization versus virtualization. Without Docker, isolation and other benefits can be achieved with the use of hardware virtualization, often called virtual machines. The most popular solutions are VirtualBox, VMware, and Parallels. A virtual machine emulates a computer architecture and provides the functionality of a physical computer. We can achieve complete isolation of applications if each of them is delivered and run as a separate virtual machine image. The figure represents the concept of virtualization. Each application is launched as a separate image with all dependencies and a guest operating system. Images are run by the hypervisor, which emulates the physical computer architecture. This method of deployment is widely supported by many tools such as Vagrant and dedicated to development and testing environments. Virtualization, however, has three significant drawbacks: low performance, high resource consumption, and large image size. The concept of containerization represents a different solution. Each application is delivered together with its dependencies, but without the operating system. Applications interface directly with the host operating system, so there is no additional layer of the guest operating system. It results in better performance and no waste of resources. Moreover, shipped Docker images are significantly smaller. Notice that in a case of containerization, the isolation happens at the level of the host operating system's processes. It doesn't mean, however, that the containers share their dependencies. Each of them has their own libraries in the right version, and if any of them is updated, it has no impact on the others. To achieve this, Docker Engine creates a set of Linux namespaces and control groups for the container. That is why the Docker security is based on the Linux kernel process isolation. This solution, although mature enough, could be considered slightly less secure than the complete operating system-based isolation offered by virtual machines. Docker containerization solves a number of problems seen in traditional software delivery, such by reducing environment complexity, isolating files, and application, organizing applications, and the last one is portability. Docker is not the only containerization system available on the market. Actually, the first versions of Docker were based on the open-source LXC Linux Containers system, which is an alternative platform for containers. Other known solutions are FreeBSD jails, OpenVZ, and Solaris containers. Docker, however, overtook all other systems because of its simplicity, good marketing, and startup approach. It works under most operating systems, allows you to do something useful in less than 15 minutes, has a lot of simple-to-use features, good tutorials, great community, and probably the best logo in the IT industry. With this, we wind up our first video.